Hi, everyone. So let's start going. Um, okay. Um, okay. So no one's, okay. So I think we're off this coming Tuesday, right? Right. Well, so I'll see you next time Thursday, right? Okay. So last time we left off, we were doing let me just open that up. And, um, where was it? It was over here. Yeah. Okay. So we were having a bunch of, we were showing how to do a diagram, right? Remember? Right, we're showing how to do UML diagram. So I'm using Visual Paradigm. And actually, you know what? I have a nice little, um, uh, let's just open this up. We'll just do it, it's, system, I'll just do, there's there's a nice little video, not a video, a YouTube video on this, and it's really I'll just do a little bit of it, but he explains it very nicely. So, there's actually from one of the people that sells okay, so I'm not gonna do all of it, just,
My name is Bear. Today, you and we'll start with some basic characteristics. Then we'll talk about relationships. Finally, we'll finish up by going through a few examples. All right, let's talk about some of the basic characteristics of class diagram. Now I'll explain these characteristics. I'm going to make up an example to help us with you. So let's say we're building a system for a zoo. Keep in mind, these examples I'm going to use probably wouldn't ever find related in an actual program, but humor me as I use these concepts to make it easier to understand. So, in our zoo, we want to describe the different things that are in the system. We represent these things through classes. The class is depicted with each shape here. So what's in a zoo? Well, a ton of animals. So we can create a class for our animals. To do that, you just write the name of the class in this top section. Our class is animal. The instance of that class would be a specific animal. So the question is, how would you go about identifying each instance?
okay, so how would you do, so how do we do it last time? Do you remember? Took animal and do you remember what we did? How do we show a specific type in UML? It's called, remember the word? It's a fancy word. They call it generalization. So, right, so this was that symbol, right? So the cow inherits from animal. So he's gonna show you the same thing. So, where is that? Uh, where did I put it? Oh, um, yeah, so you'll see over here, it's gonna do the same thing. Okay, we'll skip that.
You get to the bottom section here. This is where you put some of my askers change around format and the data typing. So right now, you have
Okay, we don't need this stuff.
private, phone, notice I'm using my, and you want to follow.
Okay, he wants us to buy the software. Okay. Okay, so here's where, okay. This is where he does inheritance.
Then do and five, arrow. This is an inheritance relation.
Okay, remember, we said it's also called, we also said this is called generalization, right? Okay, because because the animal is a general form of these animals.
flat fraction. In other words, you don't repeat your draw association, specify
Okay.
a whole in parts. So to continue with our zoo example, again, this is just to help explain the logic. Let's create a new class or group of tortoises. A group of tortoises is called a creek. So here's our creek class, and it's got a relationship with tortoise. Any of our zoo tortoises can be part of the creek, but they don't have to. A tortoise could leave the creek at any point and still exist on its own. That type of relationship, where a part can exist outside the whole, is aggregation. Note it, put it down. There's also a relationship where the part can't exist outside the whole. That's called composition. To illustrate this, I'm going to create a few classes. Let's just say we have several different visitor centers in the zoo. On each of those visitor centers have a lobby, bathroom. Now, if lower visitor centers come down, lobby, bathroom, that visitor center would also be destroyed. Those rooms couldn't exist apart from the visitor center that it's contained. That's composition. When a child object wouldn't be able to exist without a parent object. Another composition method is closed. Another important concept when we talk about relationships in UML is multiplicity. Multiplicity allows you to set numerical
Okay.
relationships.
Okay, that's,
But it could be
okay, we're gonna not, okay, that's, okay,
Mhm.
so okay, so that's basically what I wanted to do next. Okay, so, sorry about my phone. Okay, so basically, so far we did inheritance. Okay, now, let's say we have a case where, let's say we have um, let's say, for example, we have could everybody see it? Yeah. So let's say we have a barn class, and let's say, okay, now let's say a barn, there's two ways a relationship could occur between a barn and a cow. Okay? One way is that a cow has to live inside the barn, meaning that if it doesn't exist, if the cow, every cow has to be in a barn. Okay? Another way is that a cow could exist by itself, meaning that not necessarily by itself, but it could exist as part of other things. So, for example, it could be in a barn. I don't know. Maybe it could be in what else could a cow be in? Uh, um, a field. Maybe it lives outside, right? So let's do the first way. So the first, it's not clear what a field is. Let's do a outdoor field, right? Just so it's clear. Outdoor. Okay, so um, just because field is a little bit, in programming, it's a little bit. Okay, so the first way would be, let's say we have the cow. I think it goes from here. Keep on forgetting which one is which. So first way would be aggregation, which is that the cow is inside the barn, but aggregation has like this diamond. So it means that so that's the empty diamond. Okay, that's the clear diamond. That means that the cow is inside the barn, but cow could also be inside the field, right? Like I did it the wrong way. Um, so okay, so this means that these diamonds mean that the barn, the cow could be either, it doesn't have to be inside either one, could be in one or the other, or maybe both, right? But let's say we'd have, let's say, another class called just drag this guy over here. Okay, a cow, a part of a cow, the cow tail, right? And the cow tail can't exist by itself, right? The tail is like the end of the cow, right? So that has to be part of the cow. So we're gonna do a different type of relationship. We're gonna show like this, cow tail. And this is going to show composition. Okay, so uh, doesn't let me do that. Anyhow, okay. So the way we read this is that an animal, a cow is what? What is a cow? Cow is a what? Animal. What has cows inside of it? I'm sorry. Yeah, either one or the other, right? Either the barn or the outdoor field could have a cow. What must a cow tail belong to? A cow. Very good. Okay. Now we'll do we'll do two more relationships. So there's one called no, let's say we have um, I'm not good at this dragging stuff. Let's say we have a um, farmer, and the farmer could have a undefined relationship. It's just called a relationship. It just means that there's let's say with a barn. Okay, so the farmer has some type of relationship with the barn. Or okay, we don't, this is a regular line. So all it does is it specifies that there's some type of connection, but it doesn't really specify in detail the connection, right? The association. It's like a more of a vague term, right? So, and there's one more one that we're going to do, and that's dependency. Okay, and then that's it. So we could keep on going. You see, there's a lot of other ways you could do it, and but right now we're just going to do inheritance. That's this one over here. Composition over, I'm sorry, aggregation and composition over here, and association. And we're going to do one more, dependency. So let's say, for example, we have another class called hay. Does anybody know what hay is? Hay is what cows eat. It's like dried grass. Hope I spelled it right. So over here, if the cow eats and hay, so then there's a dependency between cow and hay. So I think we go like this, and we would show a dependency. I'm probably doing it the wrong way. Wrong way. Yeah, so it goes, I forgot which was, it goes this way. Hey, did I do, I keep on forgetting which way. No, I did it the wrong way. I have to go to hay and say it's dependent on cow. Cow is dependent on it. Oh, no, I'm sorry. Oh, no, that is actually right. Cow is dependent on hay. I think that actually is right. Okay, so in this case, I hope I have it right, that the arrow the right direction. It's not that important, but the point is that what is this relationship? Remember, we said there's different types of relationship between objects. So over here, we have is a relationship. Here has a relationship, right? The barn and the field have a cow inside of it, but they belong to it. And then we have association where it's just undefined, just means there is some type of relationship. And here is another way that two objects can have relationship is where the cow is dependent on hay. So hay isn't part of cow, but cow needs it, otherwise like it won't exist, right? I'm not going to, they won't be able to eat, right? So let's just do a see in code what that would look like. Um, and then we'll do another example, okay? So um, actually, let's just do another example first. So I have this thing over here. Um, sorry about that. Okay. Yeah. So let's look at this example over here and forget about the, right now, let's forget about the numbers. I just did something bad. Okay. So over here, let's look at this diagram over here. So over here, okay, we're going to leave out the numbers for today. So let me just, could you see it? Could everybody see it? Should I turn off the light? Um, So, okay, so over here, so first of all, where's inheritance? Let's start with that. So what is a payment, right? What classes belong to payment? Well, we see that this is inheritance symbol, right? So that means that cash, check, and credit all inherit from payment. They're a form of payment. Remember, just like we had different types of animals, right? We said like tortoise, whatever the example was. There's different forms of an animal, right? Remember this diagram? Where was it? It was whatever. We saw that in the YouTube video. And I'm going to post the link so you could look at it at length. But over here, though, um, the cash. So in other words, all of these are payments, right? So what do cash, check, and credit share in common? I mean, what variable do they all share in common? They all have amount, right? Because they all are payments, so they all have that as part of themselves, right? So a check has an amount, a cash has an amount, and a credit has an amount. I don't know what amount it is, but I don't know what it means, but for a credit card, what amount could be either how much you borrowed and how much you owe, how much is left. I don't know what they would do with amount for a credit card, but cash makes sense. It's an amount. And um, okay, so that's these three. Okay, this is inheritance. Then we go over here and we see what is the relationship between customer and order. Actually, it says, right? It says over here, there's a line, so that means there's a association, right? Right, so we just know that there's some type of relationship between customer and order, but we're not specifying how they're related. Over here, though, in order, we're showing that the order detail is is aggregated inside the order, right? And this is a little bit wrong, right? Because should this really be aggregation or should it be composition? What do you think? Would you say composition, right? Right? Because why? Because you can't have an order detail without an order, right? Doesn't make sense, right? You can't have an order detail floating around. So this is probably a mistake, and they probably should have done composition, right? You understand? Does everybody understand that? Why it makes more sense to do composition? Whatever, but no, they should have done a black diamond, right? A filled in diamond. And then over here, it's showing us a there's not a dependency. I don't know why they put the arrow there, but it's showing us also a relationship. I forget about the arrow. We're not going to get into that. Okay, but so we saw three. So we see um, we missed out on composition, and we didn't show dependency. Um, so if you want, let's just Google something and let's look at an image. I like just looking at images of a um, class diagram. Um, okay, so um, okay, so this was our first example, right? So in this example, we have the animal, which has two things and two methods, two variables, two methods, and duck, fish, and zebra inherit from it, right? So this is just showing inheritance, right? So that's example over here. Over here, let's see what this is showing. Um, just like a big diagram. Uh, where is our class diagram? Uh, this actually explains it very well. Maybe it was on top. Um, okay. No, where was the one that I saw in the Google Images? They had another one. Actually, this is a very good. This explains all the. Oh, here we are. So, though I don't. Okay, so over here, okay, we don't worry about the. Remember, we just it's not good. Um, okay, forget about that. That's too complicated. We're not doing such complicated stuff. Um, let me find one more. This is similar to what we have. I just want to find something with. Okay, so let's just look at this. And okay, okay, here. So over here, we have a patient is um, in order to visit, and the address has to belong to we have a visit and we have a home address. I'm not sure what the plus means, but the address and the visit have to belong to the patient, right? They can't belong to, anybody else, right? So, and then over here is showing association between company and employee. And over here it's showing again association, over here it's also association. So maybe that isn't so cool. Um, and then over here, we're showing that the contact is inside, has to be inside the address book. And then, but the contact could be could belong to this group, but could probably belong to multiple groups, right? That's why it has the aggregation, right? I don't know about that. Do you have contact groups on your phone? I've never seen that. Um, but, but apparently you could have the contact, according to this diagram, could be in maybe other things besides a contact group. Maybe it doesn't have a contact group, right? Um, and then over here, the address book is part of the account. Okay. So, but it could be the address book could be, doesn't have to be an account. I don't know how that would happen, but that's what it's saying. Okay, so you could have a address book without having an email address. That doesn't make any sense. Okay, but that's what they have. Okay, so I think should I do another example or we did enough? Let me know. Maybe this one. You just go through them and look at them. Um, here we have here we have an example of a dependency, which is, let's say damage file. This is showing dependency because it's a dotted line. Um, and then over here, it's showing that the customer file has people, has persons, and then persons are dependent on the address. Oops. And then a company insurance claim has to belong to a company, but a policy um, a car insurance policy inherits from policy, right? So anybody have any questions? Right, let's look, so in other words, what is the relationship between damage file and assessment report? What is the relationship? Right, it's a aggregation, right? The assessment report could belong to the damage file, but could also belong to other things. And a damage file could have a insurance claim, but insurance claim could also belong to something else. And then over here, the insurance claim has to belong to a company, right? You see this relationship? But in a policy, has to belong to a company, but it could be, but it could belong to an insurance claim. Did everybody see all that? Right, did everybody see the relationship? Insurance claim has to belong to a company, right? Because I guess where else are you have I guess, I guess over here, company is insurance company, and the policy is um, has to belong to a company, but you don't, just because you have insurance policy doesn't mean you have a claim, right? Right, just because you have insurance policy, God forbid, doesn't mean just you have, your car is insured, doesn't mean that you never had any claims against it, right? So it could belong to insurance claim, but it doesn't have to, right? So, um, and then person is dependent on address. Okay, and okay, I mean, maybe I'm sorry, I shouldn't let you try to. Anybody want to try to guess a few? Let's find one that's a little complicated. Oh, here. Okay, this one I'm going to let you speak. Okay, so what's the relationship between the library and the user? Anybody want to say? The library is up here, right? So what's the relationship between library and user? What would you say? The user what? Has to belong to the library, right? It's composed, right, by the library. What is the relationship between user and staff and user and student? What? Inheritance, right. So a student is a user and the staff is a user also, right? So both the student, now does an account belong to a student or a staff? Account, but I'm sorry, I shouldn't have clicked that. What did I just, let me close some stuff. Okay, so going back to here, so the account, right? What classes does it have to belong to? Right, either a user or a staff or a student, right? Because it's composed by user. And then staff and student also all inherit from user. So I know that account has to belong to one of these three, either user, staff, or student. Probably user is never going to be used by itself. You're either going to be staff or student, but we don't know for sure. Okay, and a book, what about a book? What's the relation between a book and a user? Association, right? We're not defined really. But a book has to belong to who? Book has to belong to the library, right? Because it's composed, it can only belong to the library, right? In librarian, we just have association with um, the library, and the library database is also associated with the account and I don't exactly get that, library database. Why would that be associated with account? but associate also with the librarian. And, okay, whatever, but that's what they're showing, right? I'm just reading the diagram, I'm not saying if it makes sense, right? So the library database is connected to the account and the library, the whole library, right? Okay, good. So, um, back to our diagram over here. So, right, so these are the five things I wanted to show. So inheritance, right, which we said is this one over here, right, the arrow. The aggregation, which we said is this over here, the empty diamond. The composition, which um, we don't have a good picture of it. Um, Let me just take a picture of this, put it in there. Actually, we just had, I'll just put it together. Okay, so this will be composition, and we'll put that in here. Um, this is composition over here. And then, oops, goes over here. And then we do aggregation. We'll do that over here. So actually, I'll just do whatever's here. This is inheritance, so I'll do like this. This is inheritance. And then aggregation is, let's find aggregation. Uh, Here we have aggregation. So where is it? I have to close it. Sorry. Okay, here's aggregation. And come on. I think if that's open. And so that's aggregation, and then we have association, which is easy. I don't even have to bother. That's just a line. And then dependency is a dotted line, right? Just a dotted line. So something like that, right? So that shows the dependency. Okay, don't worry about which way the arrow goes. Okay, so that's a dependency, okay? So those are the five things that we want to know. Okay? And then we also spoke about that there's the name of the object, the attributes, and the methods, which are basically variables in the methods, and then the relationship we just did. And then this we're going to do another time, which is the quantity of the relationship. So we're going to do that a little bit later, okay? I don't want to get too much in one day. Okay, so so that's it for now for UML. Then a later time I'm going to multiplicity. Okay. Okay, to be done. Be done at a later time. Okay, so that's that for that. Okay. And next, what I wanted to do was to look at it in code. So, in other words, what does it look like in code? So, where is it? It's called class. I have too much junk in here. I'm always scared to to delete stuff. Oh, here we are. So let me just open this up with IntelliJ and just have a quick look at how it looks like in code. I don't know, how does it know that it was copied from the internet or something? Like, how does it know that? Okay, so over here, let's look at a little bit of code. So over here, we have animal that doesn't show anything, right? Over here, we have a dog. So what does this show? Inheritance, right? And this we said is dependency, right? Because the eats method is dependent on the food, right? So the dog inherits from animal, but it's dependent on food, right? That makes sense? So it's two relationship, right? It has the dog is an animal, but it depends on food to eat, right? And here's food, which is just a plain class, and that's just a method. And over here, we see a relationship. What type of relationship is this? So in this case over here, I wrote aggregation, but right, because so over here, dog is inside of a person because a person has dogs, right? Right, a person could have, up to, like in this example over here, a person could have up to 5 dogs, right? That's where our code is showing. And um, in a Tesla, could he have 3 engines? I don't know. Oh, so over here, though, the point is that the engine is declared inside. I think I have to make this private, actually, to be good. Yeah. So over here, the engine is defined inside the Tesla class, so it's not accessible outside of Tesla, right? So therefore, an engine is what? Is what by Tesla? Tesla is composed of engine, right? Does anybody see that? Why did I say composition? Because this class, right, the engine is not visible outside of Tesla. So it can only belong to Tesla. Okay? Maybe I should make it car instead of, let's make it more simple. Oh, and then it's going to want me to rename the file name. Huh? Oh, and it's going to, usually it yells at me. Oh, here it is. I have to rename the file. Okay, so it doesn't like when the file name is different than the class. Okay, so this is showing that a car is composed of 3 engines, right? Actually, it could have 3 engines, but it always has at least one engine, right? Because you see in the constructor, there's one engine being created, but it could have up to 3 engines, okay? So when we do multiplicity, we'll discuss this. Again, we'll get back to this, okay? So this is how we would look in code, okay? So if I gave you this code, you wouldn't have to write it, but you could probably figure out, right, what the relationships are, right? So should I go over it or should we go on? Let me know. If you want to go over it, I don't mind, but I don't want to bore you. Uh, Again, just real quick. So we have animal by itself, car is composed. And the reason why we say composed, meaning because inside of it is an engine, our engines, and they only belong to the car. And then we have a dog where it has two relationships. It's number one, is a animal, and number two, it's dependent on food, right? So I'll give you another example of dependency. So for example, let's say I go into Maine, right? And what is Maine dependent on? What is this class dependent on? Is it dependent on anything? What would you say? It's not dependent? On what? Yeah, which is what, oh, right. So it's dependent on string, right? Because if there was no string, the class, then the code would not compile, right? So if it's dependent on something, if it won't compile without it, that means that it's dependent on it, right? If you don't have, right, you need that library, that Java library. Otherwise, right, you're gonna, right, we have this library over here called, the string class over here. Without that, we would be stuck, right? We wouldn't be able to compile, right? If I did lowercase s, right, this, like in C sharp, you could do lowercase s, right? But in this, right, this code is not going to compile, right? So it's dependent on the string class. Okay? So basically, um, so the dependency is a pretty simple idea, right? It means basically just think of it won't compile without it, right? And over here we show aggregation because the dogs are inside of a person or a person has dogs, but there's nothing special. But since the dog is public, right? It's public, so it could exist other places in the code, right? There's nothing to show that dog has to be, only a person could have a dog, right? Maybe a car could have a dog, I don't know. You know, or maybe a dog could exist by itself. Maybe in Maine, we could just do, dog equals to new dog, right? And there's no a person needed, right? A dog could be, let's say, a wild dog, so it doesn't need a person, right? A dog can exist by itself. Okay, sorry. It's hard to see what I'm doing. So dog can exist by itself, okay? Without person, right? So a dog doesn't have to have a person that it belongs to, okay? So aggregation. Uh, a dog is aggregated inside person. Okay. 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 Is that clear? With, okay. Um, Let me just fix that. Okay. Uh, okay. Okay. So that is that. And okay. Next. Okay. Are we good? So that's what this is so far what we're going to do with UML. One more thing we're going to do, come back to it, is to do a multiplicity, right? Which is the amount in other words, there are limits that sometimes we could specify the limits of a relationship. Okay, the numeric limits of a relationship. Okay, so, okay, then, okay, so the next thing I want to do is I just want to do a little bit more object-oriented stuff. So let's get that here. Okay, so far we've done the main four. Do you remember them? Encapsulation. What are the other three? Well, here's the other one, right? One is encapsulation, which means what? To protect, right, what's inside of it from being messed up. Then we have abstraction, right? Which we said is when we do something for, we provide functionality inside our object, right? Like anytime a method, anytime an object has a method, that's abstraction, right? Because it's providing some type of functionality that only exists within our object, right? So example over here, this multiply knows how to multiply, right? So that's it. So that's doing abstraction by providing me this math class over here is providing me with um, the it's telling me how to, and by the way, make it good code. Right, so over here, the multiply is providing me how to multiply, so I don't have to figure it out. And then we had inheritance, which is basically, what's the idea of inheritance? What's like, why do we want to inherit? Let's say you have a job interview here, and this guy says, okay, inheritance is a good idea. Why is it good? Like, what does it provide? Right, it allows us to do what? To reuse existing code, right? Without having to um, recreate it, right? Like with animal, anything inside the animal will be reused by anything that inherits from it, right? So that's the idea of inheritance. So it sounds like a good idea, except we said that it's a little bit too strong. Polymorphism is um, is method overloading. So um, um, actually, I think it's called parameter. I think it's called, I'm not, I think it's called method overloading. Let me just make sure it's not called parameter overloading. Quick check. Um, Method overloading. Uh, oh, so it would be overriding maybe. Uh, no. Okay. Yeah, no, it is overriding. Okay. So it's overloading. Okay. Yeah, it was right. So method overloading is where we, um, e.g., for example, S out, not S out, I forgot, it's called, let me just find it. It's easier. So if I go over here, right, so if I print something, right, so I do, so, so for example, this could print a string or it could print a number, right? Do you remember this? We did this? So, and the reason why I could do it is because of polymorphism, because it has the same name, but it's actually a different method, right? So for example, this, it takes a integer as a parameter, right? And um, the, this guy's in the way. And this one over here takes a string as a parameter. See? So they have the same name, but they're actually two different methods, right? So method overloading allows us, so I'll just put it in here. So e.g. So we paste this over here. So print line is the print ln below is actually two two different methods, but polymorphism hides that complexity. Okay, so all I have to know is call print line and it'll do whatever it does. Hides that complexity. So I don't have to worry about the type. I just use okay, or this complexity. Okay? So we have print line but it looks the same, but it's actually two different things, right? It's two different methods. So that's, it's a nice thing because then you don't have to keep on remembering which method does, when I used to code in C, we used to have like print string, print integer. We'd have to have a new method every time. And sometimes you would have print int2, which would mean like 2 bytes, print int4 for 4 byte, for like a long integer. And like you have a million methods and you have to remember each one. So, with with polymorphism, you don't have to keep on, you don't only you have to remember is print line, and then you just pass it whatever you want. And it'll figure out which method to call. Okay. And then we had um, another, um, principle where we said that we don't like inheritance, right? And the reason why we don't like inheritance is um, because um, well, the basic reason is because, okay, over here, that um, because of the is a relationship, right? Because the child is getting everything from the parent, and sometimes it's getting things it doesn't want, and then it has to fight with itself, right? Because with composition, everything the parent has, the child has. But if the child wants to do, so let's say the child only wants to do one thing from the parent, but it's getting everything. So it's stuck with everything from the parent and then it has to fight with the parent with everything else that it gets. Okay, so we don't want that war going on. So we just want to use whatever we want and not use everything. So that's why we have composition. Okay, that's why it's number 5. Okay, that's why we have this principle that we rather have composition instead of inheritance. And then the other principle, okay, does everybody understand what this means? Composition over inheritance? Like, let's look at an example here. Here we have inheritance. Where is it? Dog, right? How could this class use composition rather than inheritance? So here it's inheriting from animal. How could this possibly use composition instead? Anybody? Well, think about it. Well, let's make a new class. We'll call it, let's just copy this. And let's make a new class called dog composition. And I spelled that wrong. Okay, so it wants me to rename the file. Okay. And I'm going to have it, okay, rather than inherit from animal, I'm going to, how am I going to use animal? Let's say I want to use animal. So what I could do is I can make animal be part of me. So I could have over here, I could have animal. So rather than be an animal, I could have an animal inside of me. It sounds right. Sorry, I just can't see what I'm doing. Uh, right? So this is the alternative to inheritance, right? If we use composition. Okay, so in this example over here, we're not forced to do, right, everything that a dog does, whatever, it's fixed. Um, right, but rather, no, so let's say a dog barks loudly. And this is let's say a public void method. And I spelled that wrong. Loudly. And over here, the regular dog will have to bark loudly, right? Because it inherits from animal, right? So it's going to bark loudly until we somehow change it. But over here, with composition, we don't have to do it unless we want to, right? In other words, we're not going to, we don't have to use animal. In other words, we can only use the parts of animal that we want. So let's say animal has something called, another method called public void walk. So let's say, okay, so an animal could walk, right? So over here, the dog would have to walk. But over here, we could have, for example, um, we could have only the part of animal, I think I have too many of these, that we want. So for example, over here by eats, um, actually, does the animal eat? Actually, let's make this eats. So over here in composition, we could use just that part of animal in this method. So we could have animal eats over here. So we're going to do just what we want to use from animal and what we don't want to use. For example, the other part, which is the barks loudly, we're not going to use altogether. Okay, we could ignore it. While this guy is stuck with barking loudly. Okay, until it overrides it. Okay, and then okay, so that is the idea. And then finally, I'll end up over here is we said the open close principle, which is also the strategy and observer pattern, right? Which is that we prefer, we don't like changing code. Why don't we like to change code? What's wrong with modifying code?
You don't know.
Right, it could possibly break it, right? So modification, it's better to add code rather than modify existing code because, right, because how could you break code? The only way you could break existing code is by changing it, right? Code uh, that existing code that works can only be broken by modification. So we rather not modify code, right? Because then we'll have to go back and test everything, right? We rather just add more code, so we only have to test the new code. And we go to sleep at night saying, oh no, did I break the whole system, right? Did I just make a change today, one in the morning you wake up, say, uh-oh, I messed up, this code is gonna, have all sorts of bugs, right? But rather you say, oh, I know, you know that maybe the new code doesn't work, but I didn't break anything that already exists, right? So that's a much better idea. And then the example we gave was, um, for example, the strategy pattern basically, I closed IntelliJ. Okay, we'll do this really quick. So this is like, so remember, what was the example we gave? Does anybody remember? Of a strategy or observer? Right, so like, I'll just kind of finish up in 1 minute. So, the example we gave is, for example, um, like let's say we have a duck, and the duck could have inside of it a quack behavior, right? Quack, quack, equals to new quack. It doesn't know what quack is. So it can't create it. Okay. And then we could add a quack over here, which is not even it's not a real object, but it's an interface called quack. Okay. And then the duck could have that ability to quack, right? And then, okay. And maybe I'll just do it like this and then we're done. Let me just make the constructor, which would set the quack behavior. So when we create the duck, we would pass in the behavior. So we're not changing the existing behavior. So we could keep on adding more behavior without breaking the existing behavior, right? So over here, this code is always going to stay the same, right? But what we pass in could change, right? So we only have to test what's being passed in, not the actual duck class itself, okay, or the pre-existing behavior. So, right, so for example, we could have, let's say, new loud quack, loud, loud, spelled that wrong. This could implement quack. Okay, and then okay, so that would be an example. So, and then in main, we could say, actually, we don't. Let's. We do have. Did I do loud quick? Yeah, I did loud. So, for example, in main, we could do. Um, what am I doing? We could have over here. We could have duck equals to new duck with a loud quick. Okay. So over here, we're passing in the behavior of the duck. Okay? So I'll see you a week from today, right? Okay. Let me turn the lights on the one who killed himself. All right. Did you have trouble getting in?
Yeah, the doors are kind of wide.
What?
The doors are wide.
Yeah, what's going on? No, not usually when I come. Okay, and somebody please give a presentation.
Yeah. Actually, cool.